Welcome to this morning's Build It session. This is Fyodor, who really doesn't need any introduction. I'm going to talk to you about Nmap, voted a few years ago one of the top network security tools. So I'll get out of the way.
Thanks, Crispin. Can everyone hear me all right? Yeah. Good deal. Well, like he said, my name's Fyodor from insecure.org. I'd like to thank you all for coming and all my friends at Shmoo for inviting me. I'm a big supporter of sort of community hacker cons. I think they allow a lot of the people, like the hobbyists and amateur researchers, who may have a passion for the technology, but maybe not the corporate backing to spend thousands of dollars on a ticket to attend. So those are great. Today I want to talk about advanced network reconnaissance with Nmap. There are a lot of security people who use Nmap, but many of them don't understand its full power. And Nmap deserves a part of the blame for that, for being too helpful. For example, if you run the scan nmap scanme.nmap.org, you're leaving Nmap to choose the scan type, the timing details, the target ports, the output formats, the source ports and addresses, and much more. In fact, you can even say -IR and let Nmap choose your targets for you. So this makes Nmap easy to use by hiding this complexity, but also easy to grow complacent with. Many people never really explore the literally hundreds of options that Nmap options for more powerful scanning that Nmap offers. So in this presentation, what I hope to do is give 3 real-life tasks and show how you can use Nmap effectively to solve them. Now, I kind of chose them to be relevant to your average ShmooCon attendee. So the tasks are bypassing firewalls, defeating intrusion detection systems, and scanning for pornography on the net. Now, I'm also going to introduce a new version of Nmap, special for Shmoo. Version 3.97 Shmoo is available at this URL here, and I'll be talking about the new features shortly. Also, these slides are available at that URL. I think I should give fair warning now that this presentation does include real unsanitized IP addresses and host names. That's because I trust you guys not to abuse the information. Also, you know, if there are any black hats in the room, you know, I'm sorry, but I'm going to have to ask you to either leave now or when the IP addresses come on the screen, just cover your eyes if you would. Before I begin, it would help to get an idea of how much introductory Nmap material I need to cover. Could I get a show of hands from anyone who's ever used Nmap? Okay, I guess we'll skip Nmap for Dummies then and move directly to our first mission, which is also the easiest. And it's to penetrate SCO's firewall to discern all of the open TCP ports on docserve.caldera.com. Now, I felt kind of bad about picking on SCO here, because at one time they sort of seemed like a threat to free software with all their Linux lawsuits and so forth. But now they've sort of devolved into a rather pathetic joke. And so I feel like I'm kind of beating a dead horse. But it's a very fun horse to beat, and so I thought I'd give it a try. You guys all probably know that Caldera changed their name to SCO way back when, but apparently changing name server names hasn't happened yet. So let's see what we can figure out about this document server that they've got. We want to find all the open ports. And when you want to find all the open ports, the first thing you usually do is a SYN scan. That's Nmap's default for good reason, because it's usually the most effective. So we say Nmap, do a SYN scan, use aggressive timing options, and you give the host name. And it chugs away for a little while. And it gives us 3 ports. 80 is open, 57 is open, and 113 is closed. Well, we have some open ports, but are we done yet? I'm afraid not, because if we look up above that, it says the 1,669 ports scanned but not shown below are in the default state of filtered. Oh, well, that's a bummer. So we may have gotten 3, but there are still almost 1,700 left over to discover. And in fact, you know, of course, there's 65,000 ports, but sometimes it makes sense to just start out by scanning Nmap's default port selection until you figure out what works, and then you'll do your big 65,000 port scan. So if the SYN scan didn't tell us what we need, maybe we should branch out and consult the man page a bit and try some other scan types. The next one we're going to try is a fin scan. And this is a great one since it doesn't include the SYN flag in the TCP header. It's able to cut through a lot of stateless firewalls that just try and block connection initiation attempts. So with the fin scan, it comes through and it gives us pages of ports. Many of them had to be cut just to fit on this slide. And here the default state is now closed. So it was able to figure out the state of 1,632 ports, but a lot of these interesting ones, it doesn't know for sure. It says open or filtered, because the fin scan, if it gets no response back, it says, well, that's what happens with an open port, but if there's a firewall somewhere in there blocking our packets and the probe or its response is blocked, you'll also get nothing back. So we're really not sure. And in terms of whether you want to potentially brute force the port or something, it's critical to know whether it's filtered or open. So we're going to have to try yet again something a bit different. And this time what we'll try is the ACK scan. We give this one a shot, and it's a lot like the fin scan in that, no SYN packet so we can get through the stateless firewalls. But it has advantages in terms of being able to distinguish the filtered ports from unfiltered. So this time it tells us 3 ports that are interesting, 135, 1434, and 32777 that are filtered. And all the rest, it says, are unfiltered. Well, that helps us a bit, but what unfiltered really means is that Nmap can talk to the port, but it doesn't know if it's open or closed. So there's still some information missing that we want to know. But what you can do if you're clever is combine these results a bit. And so, for example, let's look at what happens with the telnet port. The fin scan told us that port 23 was open or filtered, whereas in the ACK scan, 23 is up here in unfiltered. So if one says open or filtered and the other one says open unfiltered, then that leaves you just open as the likely scenario. Let's do one other example. Port 135, we see here, was also open or filtered, but here it says 135 is filtered. So instead of being open, this one appears to be in the filtered state. So sort of by combining the results of several scans, you can often divine the more detailed information you're looking for. So in this case, what looks to be the case is that out of all the 30-some odd ports that are shown here, all of them are actually open except for these 3 filtered ones. So that's quite a bonanza when you're doing a port scan, because surely with all these open ports, you can find one that's exploitable. But, so now we think we have our answer. But you can never be so sure. If I've learned one thing from, writing Nmap, it's that the networks can be tricky and unpredictable, and you never really know for positive what's going on. So it's always best, if you can, to try and figure out what you want another way and compare your results and make sure that everything matches up as you expect. So we're going to try yet another scan, and that's called the window scan. And it's exactly the same as the ACK scan in that it sends an ACK packet and it gets a reset back whether the port is open or closed, but it takes note of one subtle extra detail, that the resets many hosts send back, if it's from a closed port, they'll send a TCP window header value of 0, but for an open port, they'll send the same window size that they would have sent if it was a SYN ACK, and you had sent a SYN packet. And so by looking at those packets carefully, Nmap's actually able to divine which of these ports are open and which ones are filtered, and all the rest are in the state closed. And so this actually matches up perfectly with what we were expecting from our previous scan, in that the vast majority are open, way more than there should be, and then there are 3 of them that are filtered. And in this case, you see I added -p- to say truly scan every single port. So with that, I think we've accomplished our mission of finding the open ports on this server, and that lets us go on to our next mission, which is to sneak past all of the Nmap-related Snort IDS rules. Now, before people start throwing Shmoo balls at me, let me say that Snort is a great IDS, and I like it, and it's a fellow open source tool. So I'm actually using it as an example, for that reason, to show, if it's so easy to get past even a good IDS, the rest of them are a piece of cake too. And because the reality is, IDSs do, a lot of good things for you, but a skillful and a dedicated attacker is generally not going to have much trouble getting past them, no matter what you're running. The good news is that most of your attackers aren't actually skillful and careful, so they can still be pretty useful. Let's start with the Nmap-specific Snort rules. So I went to SourceFire's website on Thursday to grab their latest rules and see what I could get. And it gave me a bunch of grief about required registration, blah, blah, blah. And I was kind of grumbling and tried to register the name registration sucks. And it was like, I'm sorry, someone's already taken that. But eventually, I managed to download the goods and uncompress them. And I did a grep in the rules directory for all of the alerts that contain the string Nmap. Now, I don't know if you guys in the back can even read this text, but I'll try and go over it, what each one does and how you would bypass it. The first one is an ICMP rule that says if the type is 8, an ICMP echo request or ping packet, and the data size is 0, then send an alert, ICMP ping Nmap. And true, that's the default. Nmap doesn't send any data by default because it's more efficient to just send the bare header. But if you are worried about this sort of rule, you just add the -- data length option with like 64, and then it'll look like any other ping packet and not flag. Then we'll take the next one, which is a TCP alert with the flags fin, push, and urge, and it says, hey, Nmap Christmas scan alert, alert. But really, you can use the Nmap -- scan flags option and give it the argument fin urge, omit the push. The scan will work exactly the same in almost every case, but you'll avoid the rule. The next one is a web attacks rule. It says if I see communication to a web server and it contains Nmap space, then probably someone's hacked the CGI and is trying to use it to run Nmap. Now, that doesn't even involve, most people who are doing their normal Nmap scanning. But if you did want to defeat that rule, rename Nmap, or if it's already on the machine and you can't rename it, you can obviously execute commands in this case. So you could use variables or whatever you'd like to mask the actual name so that it doesn't contain those exact 5 characters in a row. The next one is a TCP alert that says if you have the ACK flag set, but an acknowledgement number of 0, then flag an alarm that it's an Nmap ACK scan. And that actually was a bug. Nmap would send that sort of strange packet back in like 1999. But if you have a modern version of Nmap, that's not going to be a problem. And the Snort people finally recognized that, and in 2.4 they moved it to the deleted rules. So no one's going to have that enabled anyway. The next one is an OS fingerprint rule that says if you see the sin, fin, push, and urge flag set, alert that it's an Nmap OS fingerprinting attempt. And first of all, that one's also in deleted rules, so people aren't going to have it enabled. But if they did, it's just one line of code to remove that one test out of the many OS detection tests, and you're still going to get reliable results. And so it is a bit more of a pain. You have to modify your scans a little bit, but if you want to get by them, you're not going to have much difficulty. So with these Nmap-specific rules out of the way, are we free and clear to scan all we want? I'm afraid the answer is no. Snort, like most intrusion detection systems, also has a threshold-based system to say, hey, if you see a lot of packets that just might be probe packets in a short time, flag an alert because someone may be doing a suspicious activity. And so let's look at, Snort has had a lot of different generations of port scan detectors. I'm going to look at flow port scan, which is an interesting one from Snort 2.2, and show how that works. The first mode it has is called fixed window detection. And so I grep the snort.conf, and it says, if you see 15 packets in 15 seconds, then flag an alert that there's a potential port scan. And yeah, this is just the defaults, but the reality is that almost everyone just has the defaults, and if they change it, it's because they're getting false positives, and they're actually going to raise the thresholds to make it more easy to slip by. So if you can get the defaults, you're usually fine. And to defeat this type of rule, it doesn't take some crazy overlapping IP fragmentation attack combined with TCP segmentation things. It's just, don't send 15 packets in 15 seconds. Send 14 every 15 seconds. And yeah, that slows you down a little bit, but there's still like, 30,000 seconds while you sleep. That can allow you to scan many tens of thousands of ports overnight. You don't have to sit there and watch it. Just be a little bit patient. And Nmap actually offers several options to affect that, such as -- scan delay. It says insert a delay between each packet that Nmap sends. And you also have to remember that this rule is for all protected machines on the IDS. And so you don't want to be scanning a bunch of hosts in parallel, or you'll exceed this number. So you would also want to say --max _ host group 1 to say only scan one host in a time. And so remember, while you can do maybe 30,000 port probes in your sleep, if even that's not enough, this is by source IP address. So instead of 1 per second, if you have a class C, suddenly you can scan 250 ports per second, and then you can cut through even a very large network very quickly without breaching the threshold. This is just a simple script that anyone could write in 3 minutes that sort of shows an example of how to do this. And it's on the slides if you want to download them and check it out. But unfortunately for port scanning enthusiasts, fixed window is not the only the port scan threshold system that Snort has. It's definitely a multi-headed pig of some sort, in that it also has a sliding window support. And this one's kind of insidious, because it's built exactly for that case, where you say, well, forget it, I'll just send 1 packet every few seconds, and then I'll never get 15 packets per 15 seconds. Well, what this says is, I'm going to look for 40 packets. If I see them in a window of 20 seconds, then I'll flag. But whenever I see a packet from a host, I'm going to increase the window size, how long I'm going to let remaining, by 50% of the amount of time that's elapsed since the first packet I saw from this host. So even if you were to say, well, I'm going to wait 10 seconds between every single packet I send, well, this would still get you, because every time it got one, it would increase the window by more, and as soon as you reached 40, it would flag. Well, that's sort of a bummer. But you don't have to think all that long to see sort of some of the obvious ways to get past it and under the threshold. For example, if you send just 39 packets just like that, the window is hardly going to increase at all, because there's been hardly any elapsed time, and then you just wait 21, 22 seconds until that window expires. So it's like 39 packets, 22 seconds, 39 packets, and so there you're able to actually scan 2 packets per second. So that's actually twice as fast as the fixed window. One problem is that you don't know which one is actually enabled, or potentially both of them are enabled. But again, you don't have to think too long to say, hey, what can I do to defeat both of these at once? Well, send 14 packets all at once so that you don't violate the fixed window, then wait 22 seconds so that both fixed and sliding windows have expired, and then send your another burst of 14 packets. And so yes, that's 14 packets every 22 seconds, which sounds kind of slow, but again, that's 50,000 probes a day. So, even a big network, if you have a few dozen hosts, a few dozen ports that are likely to be interesting, that's many thousands of hosts you can scan every day for each IP address that you use. So this is, again, just another simple script that shows an example of how to do this with Nmap. Another thing is sometimes you say, well, forget all this timing stuff. This is too complicated. It makes my brain hurt. I don't want to even deal with that. Well, you have other options. One is to simply exploit the IDS. We've seen a lot of security holes, sadly, in a number of IDSs. I hate to pick on Snort again, but they just had the huge back orifice preprocessor exploit just a few months ago. ISS Real Secure had the big security hole that the Sapphire worm exploited. Ethereals had more holes than I can count. Basically, that's often an option that kills two birds with one stone. And don't forget your decoys. I won't really talk about them much since they've been in Nmap forever. Hopefully people already know about them. But they can be a nice way to sort of, if you do get alerted, they get a message like this that shows attacks from dozens of IP addresses. And they don't really know, which ones of these are the decoys and which one, if any, is the actual attacker. Unfortunately, I don't have time to do a whole presentation on IDS evasion, but there's a lot more that you can do when you want to get complex. Exotic scan flags with the scan flags option. You can manipulate the source port, IPv6, IPID idle scanning. Fragmentation now has an MTU option that allows you to specify exactly where in the packet it fragments. SOCKS and HTTP proxies, source routing, etc. And most of these, Nmap has built-in support for. And while you're doing this, I think it's important to have some fun with it. This is an old example from good old Black Ice Defender, a little program I wrote that would search on the net and find Black Ice instances, and then it would cause a critical alert for them, the red code, and then it would say the intruder whatever I want, like your mother in this case, or cert.org, or whatever I wanted. Because I really think a lot of sort of network security administrators are kind of bored with their day-to-day, watching the network and nothing exciting happening. So if you just once in a while insert a flood of critical-looking spoofed attacks, they may panic at first, but they'll eventually get the joke and appreciate it. Or maybe not. But while we're on the topic of having fun, let's move to our next topic. Our next mission is with single service discovery. And that's pretty common. Say there's a new exploit that comes out, and you want to check your whole network very quickly to find all instances of the vulnerable service so you can shut them down before the attackers do. Or say there's a new worm that like my Doom, that leaves a back door on the ports, leaves an open port listening. You want to scan and find this before it spreads too far so you can quarantine those systems. Or maybe you're doing forensics and you find that the attacker who got in left a back door on a certain port. Immediately what you want to do is scan all your machines for that and see if he's gotten into any more machines that you didn't realize. So for this example, we're going to use a sort of less common mission, but one that emphasizes the right points. So the idea is to locate web servers on the Playboy.com network that offer free images. I've had this problem where sort of the main web page requires a credit card number, but I'm kind of a cheapskate. So I was like, if you scan maybe their corporate network, maybe they've got like staging servers, development servers that may have free images hosting that you can download for free. So how are you going to do this? Well, the first step is to figure out what network you want to scan. And I won't bore you with who is, because you all know how to do that. We do a netblock search for Playboy, and they have a lot of net ranges. But I'm going to pick 216.163.128.0/20 as an example. And so most of you probably hear /20 and think 4,096 IP addresses. And that's what we're going to scan. So first we're going to do sort of the initial try. We say Nmap, do P0, because by default Nmap does two pings, ICMP and an ACK message. And so the two pings it would send to figure out if the host is up would actually potentially take longer than just scanning for the one port. And so we say don't worry about pinging, just scan port 80, save the results to a file we can grep for to find the web servers, and we give it the URL. Nmap chugs along and scans all 4,096 IP addresses, and it gives us the answer, but it takes 1,236 seconds. That's more than 20 minutes. I'm probably not even going to be interested in the images in 20 minutes. So So how can we improve that? One way you can improve it is to give Nmap little hints that you can use to help it along. Because Nmap doesn't know as much as you do, about the network potentially. It tries to do a good job of detecting, network round trip times, packet loss, and optimizing accordingly. But when you're scanning a network that's heavily filtered like this one, it's often hard for Nmap to even get enough responses to base its statistics on. So one way you can help it out is try and figure out some timing information on your own and feed those hints to Nmap. So how do we do that? Let's find a couple hosts on the network real quick and just sort of ping them to figure out how long they take, their round trip times and such. So first I try the main web server, and it gives an IP address that's not in our range. Well, we want representative IPs. So I use the host command to look at their mail servers, and it has two of them that are both in the 216.163 block that we're looking at. Normally, I might just use one representative host for this initial testing, but here I said, wait a minute. They're far apart on the network, and the names imply that one of them's in Los Angeles and one of them's in Chicago. And we want to give Nmap a good timing estimate that reflects a worst-case scenario. So we should try them both since they're far away. How do we do that? Well, let's just ping them. So I ping both of them, 5 packets each, and both ping returns 5 packets transmitted, 0 received, 100% packet loss. Well, that's a bummer. They're blocking our pings. But how can we contact them? Well, they're mail servers, so they've got to have port 25 open. So I use one of my favorite tools, hping, and I say send a SYN packet to port 25 on each of these hosts and report back. And here it does get TCP responses. And are we interested in the minimum time or the average time? No, it's really the maximum time that we want to know, because again, we still want to be a bit conservative. So the Chicago one takes 61.8 milliseconds, and LA takes 16, which is not surprising because I was scanning from California. So we'll take the 61 milliseconds and we'll say, well, things might slow down when there's a big scan in progress. The machines might be busier. And so we'll be a little on the safe side, and we'll say set the maximum for Nmap as 200 milliseconds, a little more than triple what we saw. And so we say Nmap hyphen do aggressive timing with T4, set the maximum timeout to 200 milliseconds, and set the initial timeout to 150 milliseconds. And yes, it's more than 62, but it's important to err on the side of a little bit big, because if you time out before the packets are received, it can make your Nmap scan longer, because Nmap will be retransmitting needlessly. Another thing that's helpful is to tell Nmap to scan a bunch of hosts at once so it can do so more efficiently. And since there's only one port on each host being scanned, we want a huge group. So we tell Nmap scan 512 hosts at once. So it'll knock this out in eight individual groups. Again, the rest of the options are basically the same. So we run it this time with Nmap 3.81, and it takes 868 seconds. So yeah, that's a bit better. It's 15 minutes instead of 20. But I think we can still improve on that. And how do we do that? We run it with 3.97 Shmoo, which does it in 289.6 seconds. So now we're under 5 minutes, which is about as long as I last. And so the question is, why is this one so much faster? And there are several reasons. One is that, why did this take so long? I looked into why it was taking so long, and the answer turned out to be DNS resolution. When you say -P0, that says, yeah, don't ping, but that means just treat Nmap, treat the host as up, and port scan them and so forth, which also includes DNS reverse resolution. And so for each of those 4,000 IPs, Nmap is looking up their DNS names, which is actually taking a lot longer than the port scan. With 3.97 Shmoo, one of the nice new features is parallel asynchronous DNS requests. So instead of using the system get name info call over and over 4,000 times, one for each host, Nmap now is able to do a whole bunch of hosts in parallel with its own system, which is a lot faster. Another nice thing is -- max retries. By default, if Nmap doesn't get a response, it's most likely that the port is filtered and a firewall is blocking the probe or the response, or the host is down or something like that. But it's possible, networks aren't always so reliable. It's possible that the packet was just dropped. So to be on the safe side, Nmap will retransmit at least once, and if it's detecting dropped packets on the network, it'll often retransmit multiple times because the network doesn't seem reliable. And in a pen test, you certainly want this, because you don't want to take any chance of missing an important port that could be exploitable. But for this sort of a mission, speed is more of the essence than reliability. So we do maxed retries 0. But really, under 5 minutes is good. But do we even need that DNS information at all? We just want to find web servers. And we can then just go to the IP address, or just potentially look up those web servers where the port is open. So add the -n option to disable DNS, and now it does the scan in 46 seconds. So hopefully this will kind of demonstrate why it's good to actually read the Nmap man page. A scan that took 20 minutes before, is now down to 46 seconds, thanks to, using the options to speed it up, giving it hints about network timing, understanding what it's doing so that you can disable the parts that you don't really need. But enough of this timing stuff. Let's actually get to the results, shall we? We found a lot of web servers up here. And so I was like, all right, with this many, there's got to be some good ones. So, of course, I open up Firefox. And the first one gives me this. Good old Outlook Web Access. Now, if we were trying to exploit their systems, this would be great. But it's not very gratifying given our current purchases, or our current purposes. And it looks like we don't even have a mailbox. Well, that's okay, though, because we had a lot of different servers here. So I went through them one by one, and I was kind of getting disappointed. And then I found 136.31. That one's a great one, let me tell you. It has literally gigabytes of images. It was a downloading orgy as soon as I found it. Is it 61 or 31? I don't. Oh, okay. Oh, dear. Yes. So it's got Fedora core ISO images here. We've got FreeBSD, a big directory full of images right here. And for people who's are a little kinkier, we've got CPAN. A number of these also had sort of more visual type of images, but I figured you guys wouldn't be interested in that. There's also version detection, which is something that we didn't really need for this particular example, but it's also something that you often do want to know, because there Nmap actually interrogates the port, says, hey, this is an HTTP server running, it's Apache, this version, whatever, and that can be useful if there's a new exploit out or something and you want to find a particular version, or you want to find the service if it's running on a non-default port or whatever. And you can even do clever things with it. The ShmooCon attendees might be the type to sort of take things in a more creative direction. And so really all version detection is a system for sending probes to a whole bunch of different ports, looking at responses, comparing them. And so it's actually real easy. Well, by default, Nmap just uses it for service detection and trying to get the version numbers and so forth. You can really do whatever you want with it. This is one someone wrote to scan his network for the MyDoom virus, like the day that worm came out. You could do one pretty easily that looks for open proxies by sending like a proxy request, and looking at the response. You could do one to exploit a vulnerability to, truly test. Some of the vulnerability scanners may just test for version numbers. If you really want to check this exploit, you could run it that does something innocuous on every machine on your network to try and find any that are actually vulnerable. So that completes that mission. And so now I get to the code. And the new version is called 3.97 Shmoo. And what it actually is, as you can probably guess from the version number, is we're getting pretty close to version 4.0 I hope to release in the next 2 weeks. with Nmap, it's not due to marketing reasons that we pick our version numbers. It's because I just ran out of new version numbers to give. So this is kind of a pre-release that I'm hoping you guys might want to try it out and let me know if you find any problems or bugs. And let me show you some of the new features. The first one, runtime interaction, is something that I can basically demo. Basically, if you do what happens to me a lot, is I'll say, Nmap, do a SYN scan on these machines, and then I'll wait a little while and nothing will happen, and I'll say, I want to know when it's done. I should have done verbose mode, dang it. And then I'll have to cancel and restart it again, and it's a pain. But with runtime interaction, Nmap is actually watching. So if you press enter, it'll give you an idea of how close it is to being done, how much time remaining. Yes. Apparently people like that. And there's more. If you really want to know what Nmap's doing right now, P will enable packet tracing, capital P will turn it off, V to increase verbosity, capital V to decrease it, D will increase debugging level until it's truly scrolling the screen, and anything else will just give you the statistics. So that's one that people may find handy. Apparently they do. There's the parallel reverse DNS that we talked about. Corrupt TCP and UDP checksums. This is one that I didn't have time to really go into, unfortunately, during the talk, but it's a new feature that says, Nmap, whenever you send a port probe, ask or just send a bogus TCP or UDP checksum with it. And that can be very useful because pretty much any end destination host, even a Windows machine, will check the checksum and not respond if it's bogus. But there are a lot of firewalls and IDSs out there where you'll put a rule to say respond with a reset to this type of packet, and they'll just respond anyway without even checking the checksum. So this is a good way to say, am I really talking to the host here, or is this just a firewall that's spoofing these responses and there's really no host or none that I can get to? There's also the max retries option that I mentioned. I'll just very, very quickly mention the features since 3.50, which was the last major release 2 years ago. And so this is what's going to go in 4.0 and what's in 3.97 Shmoo. ARP scanning and spoofing can be really useful. Like if you're in a conference room and like there are a bunch of ThinkPad users and one guy with a Mac, you can say -- spoof Mac Apple, and Nmap will use Apple's OUI and Mac prefix and make up a MAC address, and if someone sees the scan, you can just point to that guy. It's an Apple Mac. I rewrote the core port scanning engine to be more efficient. Diet Nmap was version 3.95's effort to reduce memory consumption and very large scans. I wrote a brand new man page and reference guide that's already been translated to 7 languages, and there are 23 more languages in the works. It takes them a while because it's 30 printed pages long, but I think it's more comprehensive in that it actually includes most of the Nmap options except for the super, super secret ones, and it's better organized. There's a huge version detection database update. 3.50 had 1,000 signatures, whereas this one has 3,000 signatures for literally hundreds of different protocols, from FTP and SMTP and other common ones to very obscure things. Version detection can now gather the OS and device type and host name. So if it says, hey, this is the Linksys WAP54G administrative web page, Nmap can tell you, hey, it's a wireless AP, the vendor is Linksys, and so forth. And you can use that in addition to traditional stack fingerprinting. Version detection rarity allows you to control how invasive version detection is. So you can do a real light fast scan, or you can say use every probe you know of, even when it's unlikely to work. The OS detection grew 50% to 1,684 fingerprints. Performance improvements on Windows were substantial. The rat bastards from Redmond actually, or I might, they, yes, and recorded. They're not going to help me anymore now. But they blocked with Windows XP SP2 raw sockets, which Nmap had used, which was a shame because it was kind of a nice API that Unix and Mac OS X and other operating systems had. But for whatever reason, Microsoft decided it was a security hole. They blocked it. There was a workaround pretty quick, but but then I wrote a faster one this summer that uses an NDIS driver that's part of WinPCAP to send, and also Doug Song's excellent libdnet to send raw ARP packets on Windows or Unix if you select that, which is actually much faster than the old system was anyway. So I like to think of this code as sort of giving the finger to Microsoft in C++. It now does MAC address printing, so if it detects that you're on a local network, it'll tell you that, hey, this is a Linksys device, or this is a Cisco, owns the MAC address prefix. It's got leet ASCII art in the configurator, so when you do /configure, it gives you cool ASCII art like Nmap and its other competitors. It now has XSL style sheet that lets you take the XML output and convert that to HTML. There's the open or filtered and closed or filtered states, which make things a lot easier for people to understand what's really going on. There's the completion time estimates if you're in verbose mode, and of course the interactive ones now as well. And then Nmap FE has finally reached the sort of 21st century and been ported to GTK2. So those are kind of the new features. I do have another thing I wanted to talk about very briefly because I'm almost out of time. And that's, I won't mention any names, but a certain other vulnerability scanner, popular vendor, has decided to close source their software for various reasons. And one of the big reasons that they stated was that open source users hadn't been contributing much to their engine anyway, so why bother keep it open source? And so I was a little concerned about that thought. So I sort of took a look at Nmap and made a list, who's been contributing to Nmap. There's been Andy Ludomirsky has done great stuff with the Windows work. Doug Hoyt and Martin Maychok has done great service detection work. Mad Hat here has done also a lot of great patches to Nmap. And so I started to make my list, and I really realized, there really is a major problem. How am I going to fit them all on one slide? And so I'm happy. Yes, these people deserve a lot of appreciation because they've really helped make Nmap what it is. And I'm gratified that they've continued to help out and bring new things to Nmap. It wouldn't be what it is without them. And so, when you try the Nmap 4.0 or 3.97, it's thanks in a large part to their work. And now I only have about 4 more minutes, so I'll just leave this up while I answer a few questions that you may have.
Your book?
Oh, the book, yes. Why did I even put that in the demo? Or in the, I send these to conferences, and then I come back and look at them and think, oh man, why did I put that? But it's actually almost done. It's called Nmap Network Scanning. And I don't know if I'm the only one who's going to be interested on 350 pages on port scanning, but we'll see. The problem is that I keep changing Nmap so fast that as soon as I get one chapter done, I have to totally rewrite another chapter. But hopefully, I'll finish the last chapter remaining soon and then get that all published.
Okay, so my question is, I've been reading on some interesting boards that the version scanning, since you're opening the format a little bit, could be used to massively distribute an exploit. Because you could scan across a whole bunch of IPs and do the version scan and pass the exploit as part of it. Have you thought about that, considered it?
That's definitely a possibility. And for your own networks, you can sort of use that in a good way because that's truly the best way to test. Well, it's one of the good ways to test whether you're affected is to just try the exploit against a wide range of your network. And so hopefully people will take that in the positive direction and say, hey, here's a simple rule I can put in my Nmap configuration so that it can actually look for that vulnerability.
As far as the service identification goes, does it go, say, for a web server or a FTP server, does it go by the banner or does it actually, test it a little bit?
Yeah, that's an interesting question. There are a lot of good, like HTTP fingerprint and other tools that out there for sort of checking services in novel ways, a bunch of different tests to try and divine what's really running. For Nmap, mostly, if it gets a banner, it usually uses that It'll use version detection probes if the service supports one, or if not, it'll try and deduce things based on error messages and so forth. But it doesn't go in a huge amount of depth for a couple reasons. One, it's a huge database with 3,000 signatures. Another is that sort of if I put some cool super secret hack in there to deduce a certain version number, the next day someone will have a patch to that service that fakes it out. So to some degree, it's more effective to use sort of the smaller tools, more obscure tools, if you want to do really, really deep testing and you think that they're spoofing you. But this tells you what the service appears to be. But like anything you get back from Nmap, for the most part, it's coming from the remote host. And so you should always take it with a grain of salt and maybe try that exploit anyway. But if you're scanning your own network, hopefully you know what you're actually running, or you have bigger problems. I'll take one more question.
Extensions to your V6 scanning. Are you going to do any additional extensions to your IPv6 scanning?
Yeah, it would be nice to support more. I have an example I use in some presentations where I scan came.net, which is a big IPv6 proponent with IPv4, and then I scan the same host with IPv6, and a lot of the previously firewalled ports are now available with IPv6. So it's definitely powerful, and as soon as I see sort of more support and usage of IPv6, it's definitely something that I would like to extend when the demand warrants it. But for now, I try and make sure that Nmap works for the basic stuff. So you can do a TCP connect scan with IPv6, version detection works with IPv6, host enumeration works on IPv6. But for like IP ID scanning and some of the scans, they're not supported yet. But I definitely will when we see more usage of the protocol. All right, thank you very much.